Hello friends, in the previous video we talked about the term called as chemical equilibrium. Today we will look at the mathematical aspect of chemical equilibrium. Let's start with a very simple discussion. Let's look at the term called active mass. Now what is the term called active mass? You are aware of a term called as mole. 120 grams of sodium hydroxide. Let's take an example, 120 grams of sodium hydroxide. The molecular weight of sodium hydroxide is 40. When you divide 120 by 40, we get 3. This 3 represents 3 moles of sodium hydroxide. Suppose this 3 moles of NaOH is dissolved in 5 liters of water. Then we get total solution as 5 liters. This 3 upon 5 represents the moles per liter of the solution. This moles per liter is nothing else but the molarity of the solution. This is same as active mass. So when we speak about the term called as active mass, it is the concentration of species in terms of mole per dm cube or mole per liter, or is nothing else but molarity. The symbol is a simple bracket. When we write bracket A, it means concentration of A in terms of mole per liter, or it means active mass of A. Again I have written here bracket A equals to 5 molar. What does this mean? This means that concentration of A is 5 moles per liter. This term is required to understand today's topic. Today's topic is termed as the law of mass action. Let's look at a simple aspect. If you burn a candle in air, it does burn. But suppose you burn this in oxygen, it burns more brightly. It's pretty simple. Air contains around 20% of oxygen, whereas pure oxygen is 100% oxygen. So the candle will burn more brightly since there is higher concentration of oxygen. This means that the rate of any chemical reaction will depend on the concentration of the substances involved. Putting it simply, law of mass action is nothing else but a relation between rate of reaction and concentrations. It states that the rate of a chemical reaction is proportional to the product of, that is multiplication of, active masses raised to the stoichiometric coefficients. Let's simplify this thing by means of a simple example. Think of a chemical reaction given in this manner. Here X and Y represent the stoichiometric coefficients. So we can say that the rate of this reaction, according to law of mass action, will be proportional to concentration of A and concentration of B, both raised to X and Y respectively. If we remove the proportionality sign, it will be replaced by a simple constant K. This K is nothing else but the rate constant for this reaction. Let's go a little further. Look at the application of the law of mass action. Here we now talk about the law of chemical equilibrium. This could also be termed as application of law of mass action. Let's go a little further. Think of a chemical reaction as given here. Suppose rate of forward reaction is represented by concentration of A into concentration of B. There are no powers here. If the powers would have been there, then they would be the indices will be representing them. Rate of forward reaction can now be replaced by Kf into concentration of A into concentration of B. Here Kf represents the rate constant for the forward reaction. Similarly, for the backward reaction, we have this representation where Kb gives the rate constant for the backward reaction. Let's go a little further. At the stage of chemical equilibrium, both the rates become equal. So we have this very simple expression. Simplifying it further, I end up getting a ratio of concentration of product and concentration of reactants. Now Kf and Kb both are constants. So Kf upon Kb represents a new constant. Let's call this as Kc. This will be the ratio of concentrations now. This is the expression for equilibrium constant. This is the expression for law of mass action. You can see this expression for mass law equation. Here Kc represents the equilibrium constant, This remains constant at a given temperature. In general, for a reaction of this type, we simply have to think that equilibrium constant is nothing else but the ratio of concentrations of product to the ratio of concentration of reactants, in which each of the concentration terms is raised to the stoichiometric coefficients. I hope this was a perfect explanation for equilibrium constant. Please don't forget to subscribe for this channel. Also, do remember to intimate your friends and forward this to your friends. Thanks everybody.